Oil platforms are taller than skyscrapers, and most of that height is underwater. From the surface, they look impressive enough, massive metal structures rising out of the ocean. But here's what most people don't realize. What you're seeing is just the tip of the iceberg. The part above water is nothing compared to what's hidden below. Some of these platforms are taller than the world's tallest skyscrapers, except most of that height is underwater, anchored to the ocean floor in some of the deepest, most hostile environments on Earth. The answer might surprise you. Building a structure that can survive in the middle of the ocean, drill miles into the Earth's crust, and withstand hurricanes, waves, and currents requires some of the most extreme engineering ever attempted. Today, we're uncovering the hidden scale and genius behind offshore oil platforms. Let's dive in right here on Simple Engineered. Oil platforms are some of the largest movable structures ever built by humans, but their true scale is almost impossible to grasp from the shore. When you see one from a boat or a helicopter, you might notice the derrick, the helipad, the living quarters. What you can't see is the massive steel framework plunging hundreds or even thousands of feet down into the ocean, all the way to the seafloor. For example, the Petronius Platform in the Gulf of Mexico stands 2,100 feet tall from the ocean floor to the top of its derrick. That's taller than the Willis Tower in Chicago. The Baldpate Platform, also in the Gulf, is 1,902 feet tall, even taller than the Empire State Building. And here's the kicker. Only about 10 to 20% of these structures are visible above the waterline. The rest is submerged, fighting against ocean currents, waves, and immense water pressure. So why build them so tall? Why not just make them shorter and sturdier? The answer is simple. Oil and gas deposits are deep, really deep. In many offshore fields, the reserves are buried thousands of feet below the seafloor. To reach them, you need a platform that can support a drill string, essentially a massive metal pipe that extends down through the water, through the seabed, and miles into the rock below. The platform has to be stable enough to keep that drill perfectly vertical, even as waves rock the structure back and forth. The most common type of offshore platform is called a fixed platform, specifically a jacket platform. Picture a giant metal tower made of steel tubes welded together in a lattice pattern, kind of like the Eiffel Tower but submerged in the ocean. This jacket structure is driven into or anchored to the seafloor using massive piles, steel cylinders that are hammered deep into the ocean bed, sometimes over 300 feet down. Once secured, the platform becomes an artificial island, bolted to the earth itself. The engineering required to build these structures is staggering. First, engineers have to survey the ocean floor, sometimes in water over 1,000 feet deep, to find stable ground. Then they fabricate the jacket on shore, a process that can take years and involve thousands of tons of steel. Once complete, the entire structure is loaded onto a barge, towed out to sea, and carefully lowered into position. But here's where it gets even more extreme. In deeper waters, sometimes over 5,000 feet deep, fixed platforms become impractical. The ocean is just too deep to anchor anything to the bottom. So engineers came up with floating platforms. These aren't boats. They're enormous structures that float on the surface but are held in place by mooring lines or tension legs anchored to the seafloor. Some of these floating platforms are as large as aircraft carriers and can house hundreds of workers. One example is the Perdido Platform in the Gulf of Mexico, which operates in water nearly 8,000 feet deep. That's over 1.5 miles of ocean below it. The platform itself weighs around 55,000 tons, heavier than a naval destroyer, and it floats. It stays in position using 9 mooring lines, each one over 2 miles long, anchored to the seafloor with massive suction piles. The entire system is designed to handle waves up to 70 feet high and winds over 140 miles per hour. Now let's talk about the conditions these platforms have to endure. The ocean is one of the most hostile environments on the planet. Waves can reach heights of over 100 feet during storms. Salt water corrodes metal relentlessly. Hurricanes can generate sustained winds over 150 miles per hour. And in the North Sea, where some of the world's most challenging offshore platforms operate, the weather is brutal year-round. Freezing temperatures, constant storms, and waves that slam into the structure with the force of a freight train. To survive all of this, platforms are built with massive safety margins. The steel framework is designed to flex and absorb energy from waves rather than resist them rigidly. A rigid structure would crack under the constant pounding. Instead, the lattice design allows water to flow through the framework, reducing the force of the waves. It's the same principle as a chain link fence in a windstorm. The wind passes through instead of pushing against a solid wall. Engineers also account for something called fatigue. Every time a wave hits the platform, the metal bends slightly. Do that millions of times over 20 or 30 years, and even the strongest steel can develop cracks. That's why platforms are constantly inspected by divers and remote-operated vehicles, looking for signs of stress or damage. Some platforms have sensors embedded in the structure that monitor vibrations and strain in real time, alerting engineers to potential problems before they become catastrophic. So why go to all this trouble? Why not just drill on land where it's easier and safer? The answer is simple. That's where the oil is. Some of the world's largest oil and gas reserves are located offshore, beneath the ocean floor. As onshore reserves have been depleted, the energy industry has pushed further and further into deeper water, developing new technologies and techniques to reach reserves that were once thought impossible to access. There's something almost surreal about these structures. Standing on the deck of an offshore platform, you can look down and see nothing but ocean in every direction. But beneath your feet, invisible below the surface, is a tower taller than almost any building on land, anchored to the seafloor and supporting the weight of an entire industrial operation. So the next time you see an oil platform from a distance, remember, what you're looking at is just the beginning. Below the waves is a feat of engineering that rivals the tallest skyscrapers, the longest bridges, and the deepest mines. These platforms are proof that when humans need to reach something, no environment is too extreme, no depth too great. The hidden scale of oil platforms might seem unbelievable, but the reality is far more impressive than most people imagine. It's a reminder that some of humanity's greatest achievements are the ones we never see. If you enjoyed this video, don't forget to like, subscribe, and stay tuned for more stories about our fascinating world. Alright, that's all for now. Thank you for watching.